Hello and welcome to Algebra 1, Lesson 23. In this video, we're going to learn about solving systems of linear equations by elimination. So in the previous two lessons, we learned about solving systems of linear equations by graphing and then by substitution. So kind of the final method that we're going to talk about in Algebra 1 is known as elimination. So another algebraic method for solving a linear system is, again, known as elimination. So the method uses the addition property of equality to eliminate one of the variables of the system. So rather than start with kind of the textbook procedure, I want to just look at two quick, nice, clean, and easy examples. And I think we can learn the basics from this, then go through kind of the textbook procedure, and then move on to some harder problems. So I'm going to start out with this system that has negative 4x plus 5y equals 11. And negative 3x minus 5y equals negative 18. So the first thing that I want to do when I'm using the elimination method is I want to take the left side of one of the equations and add it to the left side of the other equation. Now, I'm going to label these for convenience. I'm going to label this top equation as equation 1, just so I can refer to it, and this bottom equation as equation 2, again, just for reference sake. So I'm going to take the left side of equation 1, which is negative 4x plus 5y, and I'm going to add to that the left side of equation 2, which is negative 3x minus 5y. Now I'm going to set this equal to the sum of the two right sides. So the right side of equation 1 is 11, and then the right side of equation 2 is negative 18. So what's going to happen here is that one of the variables is going to drop out. And specifically, the reason for that is because the coefficients are opposites. Okay? So let's do our addition here. Negative 4x plus negative 3x is negative 7x. And then 5y plus negative 5y is 0. Right? So this variable here, y, has been eliminated. So we have negative 7x is equal to, we have 11 plus negative 18, that's negative 7. So just that quick, we have a linear equation in one variable, and we can solve this very quickly for x. Divide both sides by negative 7, the coefficient of x. That will cancel, and I will have x is equal to 1. All right, so just from using some common sense now, you can kind of think about what we would do to get y. If 1 is the value for x for my solution for the system, that means I can plug a 1 in for x in either original equation, and I can solve for y, right? I'd have a linear equation with just y in it. Very easy to solve for that. So let's just plug it into the first equation. We'd have negative 4 times 1, just plugging in a 1 for x, plus 5y equals 11. Negative 4 times 1 is negative 4, plus 5y equals 11. Add 4 to both sides of the equation. That's going to cancel. I'll have 5y is equal to 11 plus 4 is 15. Divide both sides of the equation by 5, and you're going to get that y is equal to 3. So this represents the ordered pair 1, 3. And before I move on and kind of explain why I did what I did and why it's legal, I want to go in and check 1, 3, that ordered pair, in each equation of the system. So let's start out with equation 1. We'd have negative 4 times 1 plus 5 times 3 is equal to 11. Negative 4 times 1 is negative 4. Plus 5 times 3 is 15 equals 11. Negative 4 plus 15 is 11, so you get 11 equals 11. So yes, it does work as a solution for this first one. All right, for the second one, I have negative 3x, so that's negative 3 times 1, minus 5y, so that's minus 5 times 3, and this equals negative 18. So negative 3 times 1 is negative 3, and then we have minus 5 times 3 is 15, and this equals negative 18. And it does. Negative 3 minus 15 is negative 18, so you get negative 18 equals negative 18, so it works out here as well. So now that we've verified that 1, 3, that ordered pair is a solution for the system, let's talk about what we did to get it and why this method is mathematically legal. So the very first thing I want to call your attention to is that these two equations are set up in standard form, right? It's ax plus by equals c. And I know some of you are going to scream and say, well, that's not standard form. This isn't greater than or equal to 0. Okay, I'm talking about standard form where we just think about a, b, and c as real numbers. Okay, just for this section, I want you to just think about it as a, b, and c just being real numbers, and a and b just can't both be 0. Okay, that's your only restriction. So once we have them both set up in this format, when you put the two on top of each other, it's going to be very easy to see right away if one of the variables would be eliminated through addition. And how do you tell that? Well, you look at the coefficients. If one pair have opposite coefficients, so in other words, this y variable here has a coefficient of 5. This y variable here has a coefficient of -5. So obviously if I add 5 and -5, that's going to be 0. So I'd have 0y or just 0. If I have -3 and +3, that's 0. If I have -212 and +212, that's going to be 0. We know that if we add a number and its opposite, it's 0. So if I see one pair of variable terms with opposite coefficients, I know that this is going to be a very quick and easy method to get a solution for the system. So let me erase this real quick. And let's talk about why this is legal now. Because this is probably the thing that trips students up the most. They say, well, how are you able to add this side to that side? And that doesn't make any sense. Why are we able to do that? Well, mathematically, if I took the first equation and said -4x plus 5y equals 11, you recall that the addition property of equality tells us that we can add the same quantity or the same amount to both sides of an equation and we won't change the solution. So in other words, I could add 3 to both sides of this equation and anything that was a solution before is now still a solution. So kind of expanding on that, if I think about equation 2 for a moment, and I look at this equal sign. Let's think about this for a second. This equal sign means the same as. The same as. So that means that we are saying -3x minus 5y is the same as -18. So they represent the same quantity. So what that means is that I can add this to this side of the equation. So plus -3x. Let me kind of scooch this down a little bit, minus 5y, and add this to the other side of the equation, and I've added the same quantity. This is equal to this, so I can add them to both sides of the equation legally. It's the same thing as when I added 3 to both sides of the equation. It represents the same amount or the same quantity. So let me kind of draw that like that and put same quantity. Okay, so that's why we're legally able to do that. So using this strategy, if we have one pair of variable terms with opposite coefficients, it's going to drop out and it's going to leave me with a linear equation of one variable that I can then solve. In this case, we solved and we found that x was equal to 1. Then I can plug that back in for x in any of the original equations, and I can figure out what the other unknown is. All right, let's take a look at another one. And again, we're going to look at another easy one. And we have 4x minus 2y equals -6. We have -x plus 2y equals 3. So again, you see I wrote it in the format of ax plus by equals c, ax plus by equals c. Okay, so it's already set up for you like that. Now right away, if you kind of look at things, I have a coefficient of 4 here and a coefficient of -1 here. So those aren't opposites. 4 and -1 are not opposites. I have a coefficient of -2 here and a coefficient of +2 here. Those are opposites. So -2 plus 2 is 0. So I know when I do my first step, I add the two left sides together, this variable is going to be eliminated. Now, kind of a quicker way to do this, and a lot of students prefer to use this method, you can add vertically. Okay, so you can kind of just add it the way it's set up. You can put a plus sign out here if you want. You don't need to. I never do. I just add going down. So 4x plus -x is 3x. Negative 2y plus 2y is 0y, so that's eliminated. And this is equal to negative 6 plus 3 is negative 3. So now I have a linear equation in one variable, and I can divide both sides by 3, the coefficient of x, and get that x is equal to negative 1. So once I find that x equals negative 1, I can plug a negative 1 in for x in either of the original equations, solve for y. So let's go ahead and plug into this second equation. Looks like it's easier to work with. We have negative, and then I'm plugging in a negative 1. So minus a negative 1 would be plus 1. Then plus 2y equals 3. I'm going to subtract 1 away from each side. That's gone. I'll have 2y is equal to 2. Divide both sides of the equation by 2. And I'm going to get that y is equal to 1. So this is the ordered pair negative 1, 1. Again, let's check to make sure we got the right answer. So I have 4x minus 2y equals negative 6. So I'd have 4 times negative 1 minus 2 times positive 1 equals negative 6. 4 times negative 1 is negative 4, so negative 4 minus 2 times 1 is 2 equals negative 6. Negative 4 minus 2 is negative 6, so you get negative 6 equals negative 6. So it checks out in the first one. Let's take a look at the second one. So I have negative x, so negative, plug in a negative 1, so minus a negative 1 again is plus 1, plus 2 times, plug in a 1 for y, equals 3. So essentially, this would be 1 plus 2 times 1 is 2, equals 3. We know 1 plus 2 is 3. We get 3 equals 3. So it checks out there as well. So now that we've had a chance to look at two very easy examples, let's cover kind of the textbook elimination method procedure. So the elimination method for two variables, and obviously this would be with two equations, we want to write both equations in standard form. So ax plus by equals c. And if you want to use the stricter definition, that's fine. You don't need to. You can just have a, b, and c as real numbers, where as long as you don't have a and b both equal to 0, you would be fine. The next step, and we really haven't gotten to this yet because we haven't looked at any difficult problems, we want to transform one or both equations so one pair of variable terms are opposites. And we're going to see this in a minute. In the examples we've looked at, we've come into easier problems where we've started out with one pair of variable terms that were opposites, so we didn't need to do this step. So once this is accomplished, we want to add the left sides of the equations and set this equal to the sum of the right sides. Then we're going to solve for one of the unknowns. We're then going to plug in the result from step 4 into either original equation and find the remaining unknown, and then we're going to check our solution in each original equation. All right, let's take a look at one that's a little bit harder. So we have x minus 6y equals negative 1, and negative 3x minus 12y equals 3. So if we look here, we see that they're both in standard form already. Ax plus by equals c. The next thing we want to think about is looking at the coefficients for each variable. If I look at the coefficients for x, I have a coefficient here of 1 and a coefficient here of negative 3. So those aren't opposites. If I look at the coefficients for y, I have negative 6 and negative 12. Those aren't opposites. So I've got to transform one or possibly both of the equations into equivalent equations where one pair of variable terms would have opposite coefficients. So kind of the easiest thing I can think of right now, if I look at negative 3 here, well, all I would have to do is multiply this equation here, both sides by 3, and what that would do is that would give me a 3x here instead of 1x. Perfectly legal because I can multiply both sides of an equation by the same number, as long as it's not 0, and I preserve my solution. So let me just do that down here. I'm going to drag this guy down here, and I'm going to multiply both sides by 3. 3 times x is 3x, minus 3 times 6y, that's 18y. This equals negative 1 times 3, which is negative 3. So then here, I'm just going to copy this equation. Negative 3x minus 12y equals 3. So once we've transformed this equation such that we have a pair of variable terms that have opposite coefficients, we can go through and do our add the left sides together, set that equal to the sum of the right sides. So I'm just going to add vertically. You can just add going down. 3x plus negative 3x is 0. So this is going to be eliminated. Then the next thing is we have negative 18y plus negative 12y. That's negative 30y. And this equals negative 3 plus positive 3, which is 0. Divide both sides of the equation by negative 30, and you get that y is equal to 0. All right, so we know that y is equal to 0. And again, once I have that information, I can plug that back in for y in either original equation. Doesn't matter which one. So let's go ahead and plug it into the first one. So I would have x minus 6 times 0, just plugged in a 0 for y, equals negative 1. So we know that 6 times 0 is 0, so I can just kind of cross this out, and I would have x is equal to negative 1. So x is equal to negative 1. So that's the ordered pair negative 1 comma 0. So let's check our result in each original equation. Make sure that we didn't make a mistake. So I'd have negative 1 plugged in for x, minus 6 times 0, plug that in for y, equals negative 1. We'd have negative 1 minus 6 times 0 is 0, so negative 1 minus 0 is just negative 1. So you get negative 1 is equal to negative 1. So it works out here. So let's take a look at the other one. We have negative 3x, so negative 3 times negative 1, minus 12y, so minus 12 times 0, equals 3. Negative 3 times negative 1 is positive 3. And then negative 12 times 0 is 0, so plus 0 equals 3. You get 3 equals 3, so it works out here as well. So we verified that the ordered pair, negative 1 comma 0, is the solution for our system. All right, let's look at one that's a little bit more complicated now. I have negative 4x plus 5y equals negative 12, and I have negative 4y plus 2 equals negative 9x. So the first thing that you'll notice is that each equation is not in standard form. So when you look at it and you try to compare things, it's not easy and it's a cluster. So you want to put each equation as ax plus by equals c. So this one I'm going to leave alone. This one I'm just going to move the x variable over here, and I'm going to move the constant over here. And I'm just going to do that with the addition property of equality. So I'm going to add 9x to both sides of the equation, and I'm going to subtract 2 away from each side of the equation. So when the dust settles, I'm going to have 9x minus 4y. This will cancel, so equals, this will cancel, negative 2. So now we have 9x minus 4y equals negative 2. All right, so let's erase this real quick. And I'm just going to drag this other equation down here so they're on top of each other. So we'll have negative 4x plus 5y equals negative 12. Okay, so now that the first step is completed and they're both in standard form, the next thing that I want to do is I want to look at the coefficients on my variables. So for the x variable, I have a 9 and I have a negative 4. For the y variable, I have a negative 4 and I have a 5. So I don't have anything with opposite coefficients, so nothing would cancel right now if I did the addition. So I've got to transform one or both equations to where one of the variables would drop out. Now it doesn't matter which one you pick. I could pick the x variable and eliminate it, or I could pick the y variable. Doesn't matter. Let's go ahead and work with the x variable. So I have a coefficient here that's 9. I have a coefficient here that's negative 4. So one of them is positive, one of them is negative. So kind of the easy thing to do is just multiply both sides of the first equation by 4, right? That will give me 36 here, or a 36x. And then multiply both sides of the kind of second equation by 9. That would give me a negative 36x, right? So let's go ahead and make that happen. We'll multiply both sides of this equation by 4. Let me scooch this over a little bit. And let's multiply both sides of this equation by 9. So for the first equation, 4 times 9x is 36x, minus 4 times 4y, which is 16y, And this equals negative 2 times 4, which is negative 8. Then we have 9 times negative 4x, that's negative 36x. 9 times 5y, that's going to be plus 45y. This equals 9 times negative 12, which is negative 108. All right, so now that we have transformed both of the equations into equivalent equations where through the addition process, this variable x would be eliminated, right? You have opposite coefficients here, 36 and negative 36. We can go through and do that addition step now. So we're going to add the two left sides together. So 36x plus negative 36x, that's 0, so this is eliminated. Negative 16y plus 45y is 29y. This is equal to negative 8 plus negative 108, which is negative 116. Now, if I divide both sides of the equation by 29, the coefficient of y, I'm going to get that y is equal to negative 4. Negative 116 divided by 29 is negative 4. So y is equal to negative 4. So now I can plug a negative 4 in for y in either original equation, solve for x. So let's go ahead and plug it into the second equation. So we'd have negative 4 times negative 4 plus 2 equals negative 9x. Negative 4 times negative 4 is 16, so you'd have 16 plus 2 equals negative 9x. 16 plus 2 is 18, so you'd have 18 equals negative 9x. Divide both sides of the equation by negative 9. And you're going to get that negative 2 is equal to x, or you could say x is equal to negative 2. So this would be the ordered pair, negative 2 comma negative 4. All right, so let's plug in for x and y in the original equations and make sure that this is the solution for the system. So we'll have negative 4 times, plug in a negative 2 for x, plus 5 times, plug in a negative 4 for y, equals negative 12. Negative 4 times negative 2 is 8. 5 times negative 4 is negative 20. So minus 20 equals negative 12. And this is true. 8 minus 20 is negative 12. So you get negative 12 equals negative 12. It checks out there. All right, for the next one, we have negative 4y. So negative 4 times, for y I have a negative 4, plus 2 equals negative 9 times negative 2. Plug in a negative 2 for x. Negative 4 times negative 4 is 16. So you'd have 16 plus 2, that's 18. So this equals negative 9 times negative 2, that's 18 also. So it works out here as well. So we verified that this ordered pair, negative 2 comma negative 4, is the solution for the system. All right, let's take a look at one final problem. Again, as you practice this, it becomes very, very easy. We have negative 2x minus 7y equals 14. And we have 1 plus 1/2 y plus 7 6x equals 0. So this equation is in standard form. This one's not. So let's go ahead and fix that. So because this is all addition here, I can switch the order around. I could rewrite this as 7 6x plus 1/2 y plus 1 equals 0. And I could simply subtract 1 away from each side of the equation. And I would just basically have equals negative 1. Now, a lot of us don't like to work with fractions. So it's very easy to clear fractions from an equation. You multiply both sides by the LCD. The LCD here would be 6. Let me kind of scooch this over a little bit. And scroll down. So 6 times 7, 6. The 6's would cancel. I'd have 7x. And then when I multiply 6 times 1/2, the 6 would cancel with the 2 and give me a 3. 3 times 1 is 3. So I'd have plus 3y. And this is equal to negative 1 times 6, or negative 6. So I have 7x plus 3y equals negative 6. And then my other equation again is negative 2x minus 7y equals 14. All right, so now that I have my two equations in standard form, again, I want to check and see, do I have any coefficients for any of the variables that are opposites? So in other words, I look at the x variable in each case. I have a 7 and a negative 2. So it's a no-go there. I look at the y variable. I have a 3 and a negative 7. Doesn't work there either. So now I've got to do an additional step. I've got to transform one or both equations into equivalent equations where the coefficients for one pair of variable terms are going to be opposites, right? That's crucial to the elimination method. So let's just work with x. And I see that one coefficient is 7, the other is -2. So I just like to write them out there. Think about, okay, well, if I multiply 7 by 2, I'd get 14. If I multiply -2 by 7, I get -14. So I'm going to multiply my top equation by 2. So 7x plus 3y equals -6. Again, I'm just going to multiply this by 2. I'm going to multiply my bottom equation by 7. So we're going to have -2x minus 7y. That's multiplied by 7. This equals, we have 14. That's multiplied by 7. So 2 times 7x is 14x. Plus 2 times 3y, that's 6y. And this equals -6 times 2, that's -12. Over here, I have 7 times -2x, that's -14x. 7 times -7y is -49y. This equals 7 times 14, which is 98. So now we can see that we have a 14, that's the coefficient for x there, and a -14, that's the coefficient for x there. So we have successfully transformed these two equations such that one variable is going to be eliminated when we do our next step. So in the next step, remember, we add the two left sides together, set that equal to the sum of the two right sides. So 14x plus -14x would be 0. This is eliminated. And then 6y plus -49y is -43y. Over here, -12 plus 98 is going to be 86. Divide both sides of the equation by -43 to isolate y. And you're going to get that y is equal to -2. Again, y equals -2. And now I can plug this back in for y in either original equation. I'm going to go ahead and use this one because it actually looks like it's easier. So we'd have 1 plus 1/2 times -2 plus 7 6x equals 0. So this would cancel and be -1. So you'd have 1 plus -1. That's 0. So this whole thing is just gone. So basically I have 7 6x equals 0. And we know that can only be true if x is 0. So I know x is 0 here. And again, now we just want to check the ordered pair 0, -2 in each original equation. Make sure that it's a solution for the system. So I would have -2 times x, we have a 0 for x, minus 7 times y, we have a -2 for y, equals 14. This is going to go away. 0 times anything is just 0. I have -7 times -2. That's going to give me 14. So I get 14 equals 14. So it does check out here. In the second one, I have 1 plus 1/2 times -2 plus 7 6 times 0 equals 0. We know this is going to go away because 0 times anything is just 0. And I know this is going to cancel with this and become -1. So essentially what I'm going to have is 1 plus -1, which is 0. So I get 0 equals 0. So it checks out here as well. So 0, -2, that ordered pair is a solution for the system.